I'm starting with a dataset. It has 3 columns, A, B, and C. Think of it like a spreadsheet with these columns. Each column has a lot of data points. Some of these data points might be missing, which we represent as nan, not a number. This is what we are working with. I'm using scikit-learn's _MissingIndicator tool. Features equals missing underscore only. Tells it to only focus on columns with missing values. Error underscore on underscore new equals false. Means I won't get errors if I encounter data points during prediction that were not in my original dataset. It's a really handy tool to deal with missing data points. After I use MissingIndicator I get a new set of columns. For each original column, A, B, C, I get a new column indicating whether there is missing data in that column. For example, A underscore missing will be 1 if there's a missing value in column A for that row, and 0 otherwise. It's like adding 3 new columns to highlight missing data in the original columns. The new columns will only contain zeros and ones, 1 to show where the data is missing, and 0 to show where data is present in that row of each original column. It's simple, yes or no for each original column. I'll still have the same number of rows in the new dataset as the original dataset. The number of data points doesn't change, but each row now has additional information regarding missing data points in each of its original columns. Pretty straightforward, right? These are the names of the columns in the original dataset. They are simply labels, representing various features. I'm using scikit-learn's MissingIndicator to find missing values in my data. It creates new columns showing where the missing values are. My dataset has columns A, B, and C. Some of the values are missing, represented by nan. This just reiterates that my dataset, which includes columns A, B, and C, has missing values indicated as nan, not a number. After I use MissingIndicator I get a new array. This array shows me where the missing values were in the original dataset. The new array has columns like A underscore missing, B underscore missing, and C underscore missing. 1 means a missing value in that column's original row. 0 means no missing value. I told MissingIndicator to only look for missing values and ignore other data. So I only get the missing value indicator columns in the transformed array and the original columns are not included. I set this to false to prevent errors if I later use MissingIndicator with new data it hasn't seen before. I see that you're asking about the error underscore on underscore new parameter in scikit-learn's MissingIndicator Setting error underscore on underscore new equals false is like giving MissingIndicator a safety net. It means if you later try to use the missing indicator on new data that has features it didn't see during training, it won't freak out and throw an error. Instead, it handles those new values gracefully. That's what makes error underscore on underscore new equals false so useful. It makes your code more robust. I'm focusing on the number of rows. You'll notice that the transformed dataset after using MissingIndicator maintains the same number of rows as the original dataset. Think of it this way, each row represents a single data point, and MissingIndicator simply adds information about missing values. It doesn't remove or add data points themselves. So, the row count stays consistent. This is about the type of values. Let's be clear. MissingIndicator only produces binary outputs. A 1 means a missing value was present in the original dataset for that specific row and column, and a 0 means it wasn't. It's a simple yes, no indicator for missing data. Pretty straightforward, right? I'm using scikit-learn's MissingIndicator, a tool that helps me deal with missing data in my dataset. It's a powerful feature. This is my starting point, the dataset I'm working with. It has columns A, B, and C, and some of the values might be missing. My dataset has 3 columns named A, B, and C. Each column represents a different variable or feature in my data. I use the MissingIndicator function with 2 key settings. Features equals missing underscore only tells it to only create new columns for columns with missing values. Error underscore on underscore new equals false makes sure I don't get errors if I later use it on new data with values it hasn't seen before. Pretty neat, huh? This is the result after I apply the missing indicator to my original data. It's a new array, completely different than the original dataset. After using missing indicator, I get 3 new columns: A underscore missing, B underscore missing, and C underscore missing. Each column contains only zeros and ones, indicating whether the corresponding value in the original dataset was missing, 1, or not, 0. The transformed array has the exact same number of rows as the original dataset. Each row still represents the same observation. I'm asked to figure out which statements are true about the array created by missing indicator. This statement is true. The missing indicator only creates columns with binary values, 0 or 1, to indicate if the values are missing or not in the original dataset. This is also true. The number of rows remains unchanged after using missing indicator. That's absolutely correct. Setting error underscore on underscore new to false is like adding a safety net. If I use the missing indicator with new data later, it won't crash. It handles unseen values gracefully. I'm using Sklearn's missing indicator to handle missing data. I've set features equals missing underscore only which means I only create new columns to indicate where missing values were originally located. I also set error underscore on underscore new equals false which means I won't get an error if I try to use this on new data with features the missing indicator hasn't seen before. After running missing indicator, I get a new array. This array shows me exactly where the missing values were in my original data. The new array uses only zeros and ones. A 1 means a missing value was present in the original data for that row and column, and 0 means there was a value present there. The new array has the same number of rows as the original dataset. Each row still represents the same data point, just with added information about missing values. I get 3 new columns in the transformed array. Each new column corresponds to one of my original columns, A, B, C, and indicates whether there was a missing value in the original column for that row. It's important that these are additional columns. Missing indicator does not modify the original columns themselves. It creates new ones showing where missing values were. I set this parameter to tell Sklearn to only create new columns for features with missing values. Because I assume each of my columns, A, B, C, has at least one missing value, MissingIndicator will create a new indicator column for each. I set this parameter to false. That means if MissingIndicator encounters new, unseen data during prediction, it won't throw an error. It'll handle those situations smoothly. This is my starting point, a dataset with columns A, B, and C, containing missing values. This is a new column MissingIndicator creates. It shows whether each row in the original A column had a missing value. 1 equals missing, 0 equals not missing. Similar to A underscore missing. This new column indicates whether each row in the original B column had a missing value. 1 equals missing, 0 equals not missing. Another new column, showing whether each row in the original C column had a missing value. 1 equals missing, 0 equals not missing. I'll get only zeros and ones in my transformed dataset because MissingIndicator creates binary indicator variables. It's a simple yes, no indicator of whether a value was missing. My transformed dataset will have the same number of rows as my original dataset. Each row in the transformed dataset corresponds directly to a row in the original. It's a 1-to-1 mapping. I'm starting with a dataset. It has 3 columns, A, B, and C. Crucially, some values are missing, represented as nan. I use Sklearn's missing indicator tool. Features equals missing underscore only. Tells it to only focus on columns with missing values. Error underscore on underscore new equals false. Means I won't get errors if there's new data during prediction that it hasn't seen before. After using missing indicator I get a new array. It has 3 new columns, A underscore missing, B underscore missing, and C underscore missing. Each column holds only zeros and ones, which indicate whether the corresponding value in the original dataset was missing, 1, or not, 0. The transformed array is the output of the missing indicator . It's a new dataset derived from my original one. It's all about showing where the missing data was, without altering the actual data itself. Think of it like highlighting the blanks. The new array keeps the same number of rows as the original. Each row still represents the same data point. I've just added information about the missing values. The values in the new columns are all either 0 or 1, representing not missing or missing, respectively. It's simple, clean, and binary. Because I said error _ new equals false the missing indicator gracefully handles any new data it encounters during prediction, without causing errors. It's robust and ready for anything. This is the core question of this problem. I'm testing your understanding of how the missing indicator works and what its output looks like. These are the original columns in my dataset. The presence of NaN shows that some values are missing. That's what makes this problem interesting.